When we look at Archimedes, we need to think about deriving an equation. So to start with, what we need to know is pressure equals force divided by area. But we need to remember that weight is the type of force that equals mass times gravitational field strength. If we look at a cylinder, we know it's got a height and we know that it's got a cross-sectional area. So we can therefore work out the volume of this cylinder. So it's the height times cross-sectional area. The next thing to think about is the weight of our column, our cylinder, is still mass times gravitational field strength, but rather than writing mass, we need to put in density times volume, because density equals mass over volume, so you can rearrange it. So that then gets plugged in instead of mass. The next step is to remember that our volume, HA, is the same as the V there, so we can also change that too and substitute it in. The final step is to then think, we've got the weight so far, but actually our original thoughts where we wanted to have pressure, so weight or force divided by area equals pressure, so we just divide our equation by A, and then we note that the A's cancel. That then gives us an equation where we've got two symbols that look similar, but we've got pressure equals height, or the depth, times the density, so the density of the liquid around you, times your gravitational field strength on Earth, 9.81. This equation then tells us that it's independent of A, so the cross-sectional area of the liquid you're in the vessel, has no effect on the pressure that you'll feel. What does have an effect is how deep you are. So the deeper you go in water, so any swimmers or divers will know, if you go down deep in water, the pressure will hurt your ears more the deeper you get. Equally, it depends on the density of the liquid you're in. So the denser the liquid, the bigger the pressure is going to be. So Archimedes' principle is as follows. The upthrust exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces. So what I've got here is a 5 kilogram block, and if you add that to the water in a Eureka can, that's going to displace the water out. And it does that such that if it's a 5 kilogram block and 2 kilograms of water are filled, that means that if you put a balance or weighed the block, it would be 3g, or in this case I'm just using kilograms, so 3 kilograms. Now I realise here I've used upward force is 2 kilograms. That's not officially right, because I should have multiplied by 9.81. However, you get the idea that if the weight acting down is 3 and 2 is up, that 2 has then been measured in our separate thing that's fallen out of the Eureka can. So that's why things feel lighter when they're in water, because they've got an upward force on them. There's a video that you may want to watch that looks quite good. So that's britannica.com/science/Archimedes-principle. I don't know if that needs to be a capital A, but it was when I wrote it down, so just try and type it in as a capital if you do want to watch that video.